For example, sulfur reacts with oxygen to form sulfur dioxide, which is acidic. Take a small amount of sulfur in a deflagrating spoon and heat it. As soon as the sulfur starts burning, introduce the spoon into a gas jar. Then cover the jar with a lid. To ensure that the produced sulfur dioxide gas does not escape, remove the spoon after some time. Add a small quantity of water into the gas jar and quickly replace the lid. Shake the gas jar well. Sulfurous acid is formed. Now introduce a blue litmus paper which turns red. The sulfurous acid turns the blue litmus to red. Observe the bonfire.
Why?
In this bonfire, there is a partial combustion. Carbon monoxide is produced. This is a neutral oxide. Nitric oxide is another example of a neutral oxide. We don't need the fire anymore. Let's put it out.
The fire is gone, but the unburnt charcoal is left behind.
That's true. Generally, nonmetals do not react with water, though they may be very reactive in air. Such nonmetals are stored in water. For example, phosphorus is a very reactive nonmetal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Yet, another important property of nonmetals is that they do not react with acids. Let's look at this small experiment. Take sulfur powder in a test tube. Add 2 to 3 ml of dilute hydrochloric acid or dilute sulfuric acid. There's no observable change. Unlike acids, bases do react with nonmetals. Reaction of nonmetals with bases is complex. For example, when chlorine reacts with a base like sodium hydroxide, it gives multiple products like sodium hypochlorite, sodium chloride, and water.
It was very interesting to learn so much about nonmetals. Now I will be able to identify the properties and uses of nonmetals.